Hello friends, this video on electrochemistry part 30 is brought to you by examfear.com. No more fear from exam. We'll take some more numericals now. It says if the current of 0.5 ampere flows through a metallic wire for 2 hours, how many electrons would flow through the wire? See, current is given and time is given in hours. We know Q is equal to I into T. What is the value of I? 0.5 ampere. And T in seconds we have to write. So 2 hours into 60, that is minutes, into 60 you get is seconds. You solve it, you get 3600 coulomb. That is the charge is transferred to the wire in this seconds. Now the question is how many electrons are there in this charge? So number of electrons, if you want, you can actually find the total charge which we have passed by the charge of one electron, right? Simple maths. That is nothing but 3600 coulomb by the charge of one electron is nothing but 1.6 into 10 to the power minus 19, almost approximately. This is also coulomb, coulomb gets cancelled. If you solve this, you get 2.25, 10 to the power 22 electrons. So that is the number of electrons that get passed through this wire if you are passing this 0.5 ampere current for 2 hours. So these many electrons will actually pass. Huge number, right? The next question is suggest a list of metals that are extracted electrolytically. As I've told that lithium, sodium, potassium, magnesium, aluminium, they are the metals. They are, in fact, copper. They are extracted electrolytically. Why? Because it is difficult to reduce them using chemical process. So electrical process is used to reduce them. The next question is how much charge is required to reduce the following reaction? 1 mole of Al3 plus to Al. See, for this 1 mole we have seen that, for example, Xn to XNF charge is required, right, for 1 mole. So in this case 3F charge will be required. And 3F is nothing but 3 into 96487 coulomb. You can solve it, you will get this value. Similarly for this, copper 2 to copper, 2F charge is required, 2 Faraday. You can just solve this 96487 coulomb. Right? You can just solve this, becomes 19974 coulomb. Here also if you see MnO4 minus to Mn2 plus, oxidation number of Mn is 2 here. Here if you find the oxidation number, Mn oxidation number will be, let's suppose, X plus oxygen there 4, so minus 2 into 4, because oxidation number of oxygen is minus 2, total charge is minus 1. You solve the value of X is nothing but minus 1 plus 8, that is 7. So oxidation number of Mn is plus 7. So it is going from plus 7 to plus 2. So the change is what? 7 minus 2, that is 5. Since there is this 5 electron change, that means 5F charge is required to reduce 1 mole of MnO4, right? That is nothing but 5F is nothing but 5 into 96487 coulomb. Solve this, you get 482435 coulomb. This much charge is required to reduce 1 mole of MnO to Mn2 plus. The question is how much electricity in terms of Faraday is required to produce 20 gram of calcium from molten CaCl2, that is Ca plus 2, and 40 gram of aluminium from molten aluminium Al2O3, that is Al plus 3 charge. Correct? Why I wrote plus 2 and plus 3 here? Because there is oxidation number of calcium and aluminium in this. If you have doubts, you can watch the chapter where we explain this oxidation number. So let's see the first question. I have Ca2 plus, it will take 2 electrons to become calcium. So that means 2F charge is required to produce 1 mole of calcium. 1 mole of calcium is what? 40 gram calcium, because there is the oxidation number. So 2F charge is required to produce 40 gram of calcium. So if I want, instead of 40 gram, I want 20 gram of calcium, what I'll do is, I'll say 2F divided by 40 into 20. What I'll get is F. So F charge is required to produce 20 gram of calcium. Pretty easy. Let's take the next example. 40 gram of aluminium from Al plus 3. So if you see Al3 plus 2, Al, it needs 3 electron. So I'll say that 1 mole of Al, that is nothing but 27 gram, needs 3F charge. So 27 grams need 3F charge. 40 grams will need how much charge? 40 gram will need 3F charge by 27 into 40. You solve this, you get 4.44F. Means you need 4.44F charge to produce 40 gram of aluminium. A solution of NiNO3 that is Ni plus 2, is electrolyzed between platinum electrodes using a current of 5 ampere for 20 minutes. How much Ni is deposited? I know the current. I can easily find the amount of nickel deposited. See, current is nothing but I into T. What is the value of I? 5 ampere. T is in 20 minutes. I'll make in seconds. 20 into 60 seconds. So all this is nothing but 6000 coulomb. So I have got 6000 coulomb charge. I know that, what I know? I know that 2 Faraday, because this is Ni2 plus, will become nickel and it will take 2 electron. So 2 Faraday charge is required for 1 mole of nickel, and that is nothing but 58.7 gram of nickel. Correct. So I have 2F required. A 2F charge will give 58.7 gram of nickel. 2F charge is nothing but 2 into 96487 coulomb charge will give 58.7 gram of nickel. How much charge I have? 6000. So if 6000 coulomb charge I'll be getting 58.7 by 2 into 96487 into 6000. Coulomb cancel, and this gram is there. Solve this, you get 1.825 grams. So 1.825 gram of nickel you will get if you will connect this circuit for 20 minutes using 5 ampere current. Three electrolytic cell ABC containing solution of zinc sulfate Zn plus 2, silver nitrate Ag plus 1, copper sulfate Cu plus 2 respectively are connected in a series. For example, we have 3 things. So let's suppose this is A, this is B, and this is C. They are connected in series, and this is zinc plus sulfate, this is silver plus, and this is copper 2 plus. A steady current of 1.5 ampere is passed until 1.45 gram of silver is deposited. So here we are getting in this 1.45 gram silver, because this is my anode, this is my cathode, this is my anode, this is cathode, anode, cathode, anode, cathode. Right, at cathode I'll be getting this 1.45 gram of silver for this cell B. Now question is, how long did the current flow? And also we define the mass of copper and zinc deposited. So first let's find how long did the current flow. See, for this the reaction we know is we have Ag plus gives Ag, 1 electron. Correct? That means 1 Faraday of charge will give me 1 mole of Ag. And 1 mole of Ag is nothing but 108 gram of Ag. And 1 Faraday is nothing but 96487 coulomb. So 96487 coulomb charge will give me 108 gram of silver. Right? So 108 gram of silver needs 96487 coulomb of charge. But the deposit is 1.45 gram silver. So 1.45 gram silver needs how much? 96487 by 100 8 into 1.45 sorry, this gram and gram will get cancelled and we'll have coulomb here, right? You solve this, you get 1295.43 coulomb. This is the charge that is required, correct? I know charge is nothing but I into T. Charge we know, current we know 1.5 ampere, I can find the time. So T is nothing but Q by, let's put the values, 1295.43 coulomb by I is 1.5 ampere. You will get in seconds, right? You solve this, you get 863.6 seconds. You can convert this into minute, divide by 60, you will get 14.4 minutes. This is the time that was required, right? So current flew for this time. Now the next question is, how much mass of copper and zinc were deposited? Pretty easy now. Since I know the amount of charge that flew, I can easily find. See, for zinc, if you see for zinc I have Zn2 plus, give me Zn, correct? So I can say that 2 Faraday charge is required to produce 1 mole of zinc. That is nothing but a 65.4 gram of zinc. 2 Faraday charge is for 65 gram. So this much charge is nothing but 1295.43 coulomb. This charge for what? 65.4 by 2 Faraday is nothing but 2 into 96487 coulomb, and this into 1295.43 coulomb. This is gram. You solve this, you get 0.439 gram. So this will be the gram of zinc I'll be getting. Similarly, we can do for copper. Copper we know. So copper we know that Cu2 plus will take 2 electrons to give copper. So I can write that for copper. For copper I can say that 2F charge is required to prepare again 1 mole of copper based on this reaction. 1 mole of copper is nothing but 63.5 gram of copper. So again, if 2F is giving 63.5 gram of copper, so this much charge, that is 1295.43 coulomb, will give me what? 63.5 gram by 2F, that is 2 into again 96487 coulomb into this much charge, 1295.43 coulomb cancel. You solve this, you get 0.426 gram copper, and that is my answer. So copper is here 0.426 gram. Correct? Let's see the application of electrolysis. We have seen this, we have seen the refining of metals, we have seen animation for this. It is used also for the extraction of active metals like sodium. It is also used for the production of water, oxygen, chlorine. We have seen that in so many numericals that water, sometimes hydrogen gas comes out, sometimes chlorine gas comes out. In fact, if you do hydrolysis of pure water, or if you do a hydrolysis of NaCl aqueous, you will see that chlorine gas comes out. Right? So it is used for hydrolysis, preparation of gases. As I've explained, it is also used for electroplating of metals. We have shown you the animation for this, and it is also used for electrotyping to create old monuments which needs a lot of human labor to create those kind of monuments pretty fast, to replicate those. These are the pretty good examples of applications of electrochemistry electrolysis process. Now let's first recap and see the difference between the galvanic and the electrolytic cell. If you see the galvanic cell, it is to convert chemical energy to electrical energy. Electrolytic cell is just reverse. It is used to convert electrical energy to chemical energy. So since galvanic energy, you convert chemical to electrical energy, work is done by the cell. But here in this case, you provide extra battery here and the work is done on the cell. Since work is done by the cell, the Gibbs free energy, the free energy of the system decreases, Here the free energy of the system increases because you provide extra energy. Generally here we have two electrodes, they are in two different half shell. Here we have generally two electrodes and they are in the same cell. This is generally, not always. Here reduction is at cathode, oxidation anode. The rule is same here also because red cat and anox is rule anox, red cat. This rule is true for all electrochemistry, whether it is galvanic cell or electrolytic cell. So anode, oxidation, reduction, cathode. Here cathode B has positive charge, here cathode B has generally negative charge. That is, as I told, the negative and positive charge actually you can't specify. You have to see the cell and then you have to find where you are getting more electrons. So here generally we have positive charge in cathode and negative charge here cathode has. This is used for energy generation. It is used as battery also, and this is used in electrolysis, electroplaning, refining, gas generation, all those stuffs. Electrolysis is used. Thank you. Visit examfear.com to watch more videos, attempt free online tests, get free study materials, find tutors and mentors, and much more. Thanks once again.